Hello, my dear students. It's a pleasure to meet you in our educational program of Geology and Environmental Sciences. In our today's program, we'll talk about the activity through the equilibrium between atmosphere, lithosphere, and hydrosphere. Let's start with the following subject. Now, my dear students, we start with the following question. What are the different types of weathering? We have two types of weathering. We start with the first type, mechanical weathering. Mechanical weathering is the breakdown of rock masses into smaller fragments of the same mineral composition as the original rock. As you see, my dear students, this is the results of mechanical weathering by breaking down a part of the rock into smaller fragments, and you find that the composition is the same for the broken rock. The following are the most important factors that lead to mechanical weathering. One of the most important factors here is an area of cold environments where water freezes, and by freezing water, its volume will be increased in the ice shape. As you see in the front of you, this water is freezed to ice, and the increase of the size of the ice will break the rock, as you see in the front of you. By the repetition of this many times, we'll get mechanical weathering. In hot regions with big differences in temperature between day and night, causes the minerals at the rock surface to expand and contract. Since the rock material are poor conductor of heat, they break off. The release of pressure also, it is another type of mechanical weathering due to the erosion of the sixth sequence of strata is responsible for the rock expansion too, and its breakage. The rock surface separates into successive spheroid shells following the direction of the giants. This feature is known as by spheroidal weathering or exfoliation. The work of plant also, it is another type of mechanical weathering. By this, animals, plants, roots enlarge the opening in the soil. Burrowing animals help in losing the soil and make it ready for transportation. Now, my dear students, we go to the second type of weathering here. It is the chemical weathering. Chemical weathering is a process by which rocks are decomposed, dissolved, or loosened by chemical processes to form residual material. Some of the processes are as follows. Water dissolution. Water, especially when it contains some dissolved matter, is a very effective agent of chemical weathering. It usually leads to the decomposition and decay of rocks by changing their mineral composition. The original minerals are changed to new ones, more stable to the new surface conditions. As what happened with the igneous rocks, they are originated underneath the earth under different conditions. We have another type, which is oxidation. In this type, chemical weathering, atmospheric oxygen attacks ferromagnesium minerals, those minerals of which iron and magnesium are the main constituents. In the same way, as when an iron water pipe rusts when iron is changed to iron oxide. We have another type of chemical weathering, which is hydration. It is another type of the chemical processes of chemical weathering. It implies that water becomes part of the chemical composition of an originally anhydrous mineral. A common example is the hydration of anhydrite, which is calcium sulfate, to gypsum. Also, chemical weathering of igneous and metamorphic rocks, where silicate minerals are decayed. This suggested a relative motion of earth pools and the land masses of the past. As compared with the present-day conditions, another line of evidence: potassium feldspars and sodium calcium, aluminum silicate, and ferromagnesium minerals, silicates of iron and magnesium, are altered to clay minerals which make the major part of the soil. Write on the cycles of erosion and deposition. For weathering to continue, the weathering products should be removed to expose a fresh surface of the rock to the atmosphere by the activity of the transporting agents as wind, running water, and glaciers. It means moving ice, aided by the effect of gravity. All of these media are changing their places under the differences in gravity, and they carried the product of weathering from the weathering place to the depositional place. The effect of gravity may be the sole transporting agents in the mountainous area, where the weathering product couldn't stay for a long time on the steep slopes of the mountains. This may move down slope in a rapid movement, such as mud flows, and rock avalanches, or the movement may be very slow, such as soil creep. Now, my dear students, wind and water as agents of erosion and deposition. Wind and running water erodes the surface rocks of the earth by carrying and transporting the products of weathering. This happens when the currents are strong and full of power and energy, but when they lose their energy and become unable to carry the fragments further anyway, they deposit these products in this respect. Wind and river could be regarded as agents of degradation too, when the eroded and removed sediments or material from one place to another, exposing a fresh surface to weathering and as an agent of aggradation or building up. When they deposit the material they carry to build up a sedimentary sequence. The role of these agents in changing the topography of the surface of the earth will be briefly discussed now. We start with wind. Wind has a powerful effect in desert area barren of vegetation, especially when loose rocks such as sand cover the surface. How wind acts as an agent of degradation. The erosion action of the turbulent wind currents is mostly due to the suspended load of sand and dust grains. In a windy or storm day in the desert, the large grains of the sand size will move and hitting people, animals, and even glass shield of cars. At the same time, the finer and lighter dust grains of silt and clay size are carried higher in the atmosphere to cause low visibility. A sand blast that continues for a long period will result in polishing and carving the surface of some fragments like pebbles, so that they acquire smooth surfaces. Also, if a rock sequence is composed of soft or weak and hard rocks like shale and limestone in a succession, one top, the softer shale will be eroded to a great extent than the overlying limestone, which cause undercutting of the limestone into hanging blocks and eventually fall on the ground. This phenomena is known as the differential weathering. As you see, my dear students, in desert area where there's many of the sand grains, as you see, in windy days they start to move under the wind action. This is a successive photography of an desert area in a windy day. Now, my dear students, we'll discuss the aggradational factor of the wind. When the velocity of wind decreases by natural forces, it will be able to carry the sand grains for long distances and will deposit its load. Usually, the surface of the deposited sand is not smooth but undulating or rippled by the movement of sand grains in the direction of wind, as you see in the figure in the front of you. We have similar ripples in coastal area under the effect of the water currents, but this is ripples in the desert under the effect of the wind power. The ripples marks are few centimeters in height and are common on sandy beach or in the desert. In cross-section, ripples marks are not symmetrical, with the side-facing wind sloping gently, while the downwind side or lee side is usually steeper. Sand dunes show the same asymmetrical feature, but are larger in size to be measured in meters or tens of meters. The sand grains move on the surface of the dune in the direction of the wind. They climb the windward side till the crest, then fall on the lee side. Sand dunes form where sand is available in beaches and deserts. In beaches, dunes are common on the Mediterranean coast of Egypt. The dunes take different shapes depending on the amount of sand and direction of wind. Beach dunes are commonly on the Mediterranean coast of Egypt. The barkhans usually seen as solitary dunes in a crescentic shape dune with two horns pointing in the downward direction. We have another type of dunes, which is longitudinal dunes. As the name implies, grow for long distances parallel to wind direction. They are also known as safe dunes, for the Arabic word meaning sword. Longitudinal dunes usually form belts that extend for hundreds of kilometers. A good example is the Abu al-Mahariq belt in the western desert of Egypt. Also, we have an action here for another factor of mechanical weathering, which is the rain. Rain also can act as both mechanical and chemical weathering factor. We have this in geological action of rain. Rainwater has a high power of dissolving constituents from the rocks over which they fall. Rain also helps in the weathering processes. The impact of raindrops, whatever small, may help dissolve a small amount of carbon dioxide from the atmosphere, behave like a weak acid, which is very effective in dissolving of many minerals and rocks. This is a part of the chemical weathering of the rain. We have a question here right on torrents as a great factor for mechanical weathering. It rarely rains in desert. However, when it rains, it may be very heavy rain, but for a short time, in which clouds give poured all their water on limited area. In this case, the ground surface becomes saturated rapidly, and water moved down slope at a very high velocity. This is what is known by flash flood. A flash flood is a flood which forms in a very short time, like a flash. They are common in the mountainous regions of Egypt, as in the Red Sea coast and Sinai. Runoff water has a high velocity and power and carries large amounts of detritus too, ranging in size from very large boulders that may reach to 1 or 2 meters in a diameter to the finest clay particles. Torrents have a damaging effect on constructions such as roads and buildings, or any other objects that come in their way. Most of the old wadis in desert represent valleys of torrents, and this is an old torrential streams that occurred in the past. When rain stops, the torrent loses its energy, moves slowly, and starts to deposit its load with the larger fragments, which are like boulders, which require the highest energy to move down the mountain and reaches nearly level surface or plain. The deposits take the shape of a cone or fan with its apex in the upstream, near the junction between the slope and the leveled area. Here, the coarse material of the boulders and pebble size are deposited, and the finer material of the sand and mud are deposited at the base of the cone. We call this alluvial fans. River and streams. Rainwater, which is not absorbed by the ground, flows in the direction of the slope. In steep mountainous areas, the stream is usually narrow at the head in the upstream and become wide, which with greater slope in the downstreams at the mouth. The river uses its load of detritus as a tool of erosion. However, the finer materials of the clay and silt size are usually transported in suspension, while the coarser material of the pebbles and sand are transported by rolling, sliding, or jump at the bottom. The size and the amount of each of the materials vary with velocity and amount of water of the river. In flat time, for example, the river carries more sediments, which are usually coarser than those transported in low water season. Now, my dear students, let's answer this question. How river act as agent of erosion? The water with load will act as an erosion, and it erodes its bank and the bottom of the river. So the river itself will erode its bank and its bottom, which leads to the deepening and widening of the river channel. Rivers rarely move in a straight line except for short distances. The normal course of a river is usually in the form of a series of small loop-like bends and known as meanders. When water changes its direction in a bend, it moves faster on one side of its banks more than the other side. The result is more erosion on one bank, causing the river to cut and erode this outer bank in the bend. At the same time, the river deposits its material on the inner side of the bend when the speed of the flow is lowest. As a result of the bend or the meander will change its position at a continuous rate of this course. This depends on the hardness of the river banks. When they are made of loose material, it means mud and sand, the currents will cut in them more easily, and the river channel will be connected through a shortcut to the downstream side, leaving the meander loop as lake. It is known as Oxbow Lake. The bottom of a river may also be abraded and eroded by its load of the sand and the gravel, especially river flowing on solid like limestone or granite. When velocity is high and the flow is turbulent, we have eddies, which means eddies currents are formed and fast water move in circles. The swirling load of sand and gravels eroded the bottom of the river, forming rounded depression and holes, usually less than 1 meter in diameter. These are known as potholes and are known in the Nile and the Cataract region. At Aswan, where the river is flowing on granite. A river, like all living organisms, passes through 3 different stages, which are youth, mature, and old age. What are the stages of the rivers? Youth stage. In the stage of the youth, the river is vigorous and erosion is rapid because of the steep gradient or slope. The gradient of river is expressed as the ratio between the difference in elevation and the distance between any 2 points on its course, expressed in meters per kilometers. Gradient usually decreases in the downstream part of the river. The river deepens its channel, which becomes V-shaped in this stage. The river gradient is usually not constant, depending on the hardness and resistance of the rocks in which it cuts its channel. It may make sharp cuts in softer bedrocks, with lakes and waterfalls being common in its course during the stage of Yas. The next stage is the maturity stage. In this stage of maturity, the stream gradient has become more gentle and erosion more slow. The ground surface is lowered toward the base level of erosion, the level below which the stream cannot erode, and will ultimately reach the lowest level, which is the sea level. During the stage of maturity, meanders commonly develop and may be cut off to form oxbow meander lakes. Old age stage is the last stage of the rivers. At this stage, the river has become old with very little energy to erode and is very close to the base level. The river channel takes the shape of curve instead of the original V shape. The curvature becomes gentle near the mouth, and the area has become almost a plain, and this area is known by peneplain area. Now, my dear students, we come to the end of our today's program. Until we meet next time, I have my best wishes and goodbye.